In Star Trek, the USS Enterprise crosses the galaxy at hundreds or even thousands of times the speed of light. It doesn't accelerate through space like a rocket. That would violate the laws of physics, because nothing with mass can reach the speed of light in our three-dimensional space. The closer it gets, the more energy it needs. Reaching the speed of light would require infinite energy. Star Trek gets around this limit with what is called a warp drive. The drive creates a moving bubble of warped space-time around the starship. Space contracts ahead of the Enterprise and expands behind it, carrying the starship inside a calm pocket of local space. The Enterprise isn't moving through that pocket at faster than light. Instead, the warp bubble carries it across the universe at an effective speed that would be impossible in normal, undistorted space-time. At the heart of every Federation starship is a warp core, a matter-antimatter reactor that powers the entire vessel. Understanding how a matter-antimatter reactor works is the key to understanding the essence of a Federation starship. Every particle of regular matter has an antimatter counterpart with the same mass, but opposite charge and quantum properties. When they meet, they annihilate each other and convert their mass into energy. Einstein's equation, E equals mc squared, explains why even a tiny amount of mass contains an enormous amount of energy. If 1 gram of antimatter collided with 1 gram of ordinary matter, the reaction would release energy equal to roughly 43 kilotons of TNT. That is almost 3 times the explosive power of the bomb dropped on Hiroshima. A starship needs that kind of power because bending spacetime requires an enormous amount of energy. In Star Trek, the warp core feeds deuterium and antideuterium into a reaction chamber. Both deuterium and antideuterium are a form of hydrogen, with antideuterium being the antimatter counterpart. When the two streams collide, they release a tremendous amount of energy. The challenge is keeping that enormous release of energy under complete control. The antimatter must never touch the reactor walls, and the fuel streams must mix at a precisely controlled rate. A serious containment failure could trigger an uncontrolled reaction powerful enough to destroy the ship. Powerful magnetic fields suspend the antimatter inside dedicated storage pods and guide it safely into the reaction chamber. In Star Trek, starships use a substance called dilithium crystals. Dilithium regulates the matter-antimatter reaction, allowing the energy to be released in a controlled stream rather than all at once. Think of it as the difference between a bomb and a power plant. Controlling the reaction turns a catastrophic explosion into useful power. The energy released by the warp core superheats deuterium into warp plasma. This plasma travels through the ship's electroplasma system and into the starship's warp nacelles. These are the long tube-like structures mounted away from the main hull of the vessel. The nacelles contain the coils that generate the warp field. When energized, the coils create layers of fields around the starship. These fields interact with subspace, a fictional region of reality where the normal limits of space and time do not fully apply. Together, they form the warp bubble around the starship. Inside the bubble, the Enterprise avoids the devastating effects associated with extreme speed, like being instantly crushed into a paste by the insane acceleration. The G-forces would reach into the millions. They also avoid the severe time dilation that would occur if the starship traveled through normal space at close to the speed of light. The ship remains safely inside the warp bubble as space-time bends and shifts around it. The Enterprise isn't moving faster than light through local space. It's space that is doing all the work. In 1994, Mexican physicist Miguel Alcubierre published a mathematical model now known as the Alcubierre drive. His solution to Einstein's equations described a bubble of warped spacetime, with space contracting ahead and expanding behind. The starship inside the bubble wouldn't exceed the speed of light. The changing geometry of space-time would carry it. To an outside observer, the bubble could cross a distance faster than light traveling through normal space. It sounds remarkably close to a Star Trek warp drive, but the equations do not give us a working engine. The original Alcubierre model requires a strange form of matter with negative energy, something we have never found in a usable form. Negative energy has only been observed in tiny amounts in the quantum realm, and it exists for only a fraction of a second. We have no way to produce and capture the amount of negative energy a functional warp bubble would require. Theoretical models that allow for faster-than-light travel demand negative energy in massive quantities. If you want to build a Federation starship, energy is not the only problem. No one knows how to create a warp bubble, how to steer it, or even stop it. Once the warp bubble is moving faster than light, signals from the ship can no longer reach the bubble's front edge. The crew could not send a signal forward to reshape the bubble, change course, or shut it down in the normal way. Faster-than-light travel would also threaten cause and effect. Under the right conditions, multiple warp journeys could form a closed path through space-time and allow a traveler to arrive before leaving. Nature may prevent usable warp drives because they open the door to time travel paradoxes. A faster-than-light warp bubble would also trap a large amount of particles and radiation along its journey, releasing them at the destination when the starship comes out of its warp bubble. There is also theoretical evidence that quantum radiation would make the warp bubble unstable or destroy it soon after it formed. This could be nature's way of preventing any possibility of faster-than-light travel. The writers in Star Trek solved these problems with subspace physics, dilithium crystals, and warp coils, along with deflector shields, inertial dampeners, in addition to a near-endless cavalcade of fictional engineering. None of it is real, but these pieces form a fictional system with its own internal logic. The beauty of Star Trek's warp drive is that it takes humanity's dream of reaching the stars and gives every part of that dream a purpose. Matter and antimatter provide the energy, while dilithium controls the reaction. Plasma carries the power. Warp coils generate the field. Subspace supports and makes the entire system possible. The warp field bends space-time, and the bubble carries the ship across impossible distances. A clever system created by the writers and producers of the TV show, not by real physicists or engineers. And that's the problem. It's all made up by the imagination, not by science. We have no way of building a warp drive today, or any time in the foreseeable future. And it could be that the laws that govern our universe forbid a warp drive system from existing. Even if the math gives a green light, it doesn't mean that the engineering will, or that the laws of the universe will even allow it. But Star Trek understood that if humanity learns to cross the galaxy, it won't be by forcing a spacecraft to move faster than light through space. It can only happen by moving space around the spacecraft.